Hello everybody. In this lesson, I will discuss various different kinds of sequences. There are sequences where there is neither a constant difference nor a ratio, but the pattern still exists. Remember, another word for a sequence is a pattern. Let's see how the following sequences are formed. When I give you the sequence 2, 5, 9, 14, can you see we added 3, then 4, then 5, etc. to get to the next term? Let me show you. To get from 2 to 5, we added 3. To get from 5 to 9, we added 4. To get from 9 to 14, we added 5. So although we added a number to get to the next term, the number is not constant. In the sequence 1, 8, 27, we cubed each number to get to the next term. So what that means is we cubed each term number. That is, this is the first term. 1 cubed is 1. This is the second term. 2 cubed is 8. This is the third term. 3 cubed is 27. The next sequence, 1, 4, 9, 16, 25. Can you see what happened? We squared each term number to get to the next term. So this is term 1 squared is 1. Term 2 squared is 4. Term 3 squared is 9. Term 4 squared is 16. Term 5 squared is 25. And can you see, instead of saying that the term number was multiplied by itself, I use the correct maths terminology. We say we squared each number. In the sequence 10, 9, 7, 4, can you see what happened? We subtracted 1, then 2, then 3, etc. to get to the next term. Have a look. To get from 10 to 9, I subtracted 1. To get from 9 to 7, I subtracted 2. To get from 7 to 4, I subtracted 3. You must be able to describe a sequence in your own words. Use the words in the pattern or sequence. And when I give you the sequence 1, 4, 9, 16, 25, can you see in the pattern, starting with the number 1, the term number was squared. So where do you find the term number? There's the term number 1, term 2, term 3, term 4, term 5. So the term number 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. In the next sequence, 1, 8, 27, 64. In the pattern, starting with 1, the term number was cubed. Again, where do you find the term number? First term, second term, third term, fourth term. So the term number was cubed means 1 cubed is 1. Remember, cubed means you multiply that number by itself 3 times. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. This sequence 1, 2, 4, 7, 11, 16. What happened? In this sequence, starting with 1, it has consecutive natural numbers as the difference between the terms. What does that mean? If you look at the sequence, to get from 1 to 2, you added 1. To get from 2 to 4, you added 2. To get from 4 to 7, you added 3. To get from 7 to 11, you added 4. To get from 11 to 16, you added 5. Now to write that in your own words, you will say in the sequence starting with 1, it has consecutive natural numbers. The word consecutive means the one after the other, and the natural numbers, they are the numbers that we count in. 1, 2, 3, 4, 5. And then they have the consecutive natural numbers as the difference between the terms. In the next sequence, 4, 5, 4, 6, 4, 7. Can you see that the number 4 is constant? And then to get from 5 to 6, you added 1. To get from 6 to 7, you added 1. So that in your own words will be, in the sequence, the number 4 stays constant, and every second number, 1 is added to form the next number. In this sequence, 3, 1, 6, 1, 9, 1, 12. What happened there? Can you see the number 1 is constant? And then we find the number 3. Can you see that there's the multiples of 3? 3, 6, 9, 12. And where do we find that? Do you agree? This is term 1, term 2, term 3, term 4. Then every uneven number, the first term, it's an uneven number. The third term, it's an uneven number. The fifth term, it's an uneven number. So the term number is an uneven number, and there you find a multiple of 3. So in your own words, in the sequence starting with 3, every uneven term number, so the term number 1, 3, 5, there is a multiple of 3. What's the multiples of 3? 3, 6, 9. With the number 1 constant as every even term numbers. Where do you find the even term numbers? They are 2, 4, 6. Can you see? They are the even term numbers, and in that position, that is where you find the number 1 constant. The pattern of seeds within a sunflower follows the famous Fibonacci sequence. Fibonacci sequence is a sequence of numbers in which each number is the sum of the two that precede it. What does that mean? If I give you this is the Fibonacci sequence, it means when you add 1 and 1, you get 2. When you add 1 and 2, you get 3. When you add 2 and 3, you get 5. In the next lesson, I will show you how to find the rules to describe the patterns. Click on the video in the left-hand corner to take you straight to the next lesson.